Hi guys, welcome to this easy maths video, and today we are looking at the 2019 Intermediate Maths Challenge. Questions 1 to 10. Question 1, what is the value of 2019 tenths? We've got answers as A is 2019, B is 201.9, C is 20.19, D is 2.019, and E is 0.2019. This is a nice easy question to start off with. We know that 1/10 as a fraction is 1 over 10. So that means 2019 tenths is going to be 2019 over 10, which is 201.9. We've got an answer for 201.9, which is answer B. So therefore, our final answer is B. Question 2. Each of the 5 shapes shown below is made from 5 unit cubes. Which has the smallest surface area? We've got 5 shapes, A, B, C, D and E. In order to calculate the surface area, we need to count the number of faces on each of the shapes, and then we add up the total areas. So using that logic, we know that the shape with the smallest number of faces is going to have the smallest surface area. So let's count the number of faces for each shape. So shape A, the first cube has 5 faces, the second cube has 4 faces, the third cube has another 4 faces, the fourth cube has another 4 faces, and the fifth cube has 5 faces. So that gives us an answer of 22. Shape B, first cube has 5 faces, the second cube has 4 faces, the third cube has 4 faces, the fourth cube has 4 faces, and the fifth cube has 5 faces. So again, that's got a total number of faces of 22. Shape C, the first cube has 5 faces, the second cube has 4 faces, and the third cube, I'm going to say, is this cube here, and that has 5 faces. The fourth cube, which is this cube here, only has 3 faces, and the fifth cube has 5 faces. So that's 5 plus 4, which is 9, 9 plus 5, 14, 14 plus 3 is 17, 17 plus 5 is also 22. And then we've got shape D. First cube has 5 faces. All of the cubes on the outside of shape D have 5 faces, so I can do 5 plus 5 plus 5 plus 5. And then the one in the centre only has 2 faces. So that also gives us an answer of 22. So we're hoping that the final shape, shape E, has the smallest number of faces because they all have the same number of faces. So shape E, first cube has 5 faces. The second cube has 3 faces. The third cube, which I'm going to call this cube here, has 4 faces. And then the other 2 cubes have 4 faces. So we've got 5 plus 3, which is 8, 8 plus 4, which is 12, 12 plus 4, which is 16, 16 plus 4, which is 20. So 20 is the smallest number of faces, so therefore shape E must have the smallest surface area. So our final answer is answer E. Question 3. There are 120,000 red squirrels living in Scotland. This represents 75% of their total UK population. How many more red squirrels live in Scotland than live in the remainder of the UK? We got answers as A is 30,000, B is 40,000, C is 60,000, D is 80,000, and E is 90,000. We need to find the total number of squirrels. So if we say total squirrels multiplied by 75%, which we can say is 3/4 as a fraction, we can say that's equal to 120,000. So if we rearrange this to work out what the total number of squirrels are, we're going to do 120,000 times 4 divided by 3. Well, we do 120,000 divided by 3, we get 40,000, and then 40,000 times 4 is 160,000. So total number of squirrels is 160,000. Okay, and we're told we need to find how many more red squirrels live in Scotland than in the remainder of the UK. The remainder of the UK represents 25% of the total population of squirrels. If we know that the total population of squirrels is 160,000, we can do 160,000 multiplied by 25% to work out the number of red squirrels that live in the remainder of the UK. So that's going to be 160,000 multiplied by 25%, which is the same as multiplying by a quarter. And of course, that's going to give us an answer of 40,000. How many more red squirrels live in Scotland compared to the remainder of the UK? Well, there's 120,000 red squirrels in Scotland, and there's 40,000 red squirrels in the remainder of the UK. So the difference is 120,000 minus 40,000, which is 80,000. We've got an answer of 80,000, which is answer D. So therefore, the final answer equals D. Question 4. A 24-hour digital clock shows the time in hours and minutes. How many times in one day will display all 4 digits 2, 0, 1 and 9 in some order? Got answers as A is 6, B is 10, C is 12, D is 18 or E is 24. What we need to understand with this question is that the 2, 0 and 1 can go in any 4 spaces, but the 9 has a certain number of limitations. What I mean by that is the 9 can only go in the 2nd or 4th space. And the reason for that is because the digital clock is a 24-hour clock, so the highest number in the first space will be 2, and then the number of minutes is represented as 60 minutes in 1 hour. So the highest number in the third space must be 6. So we can't have a 9 in the first or third space. So what we kind of need to do is we need to think about all the possible situations where we can have the 9. So the 9 can only be in the 2nd or 4th position. So if we look at the 9 in the 2nd position, there's one slight problem here, and it's that we can't have a 2 in this first space, because that means we're going to have the 29th hour. And of course, this clock only goes up to 24 hours. So we can either have a 0 in this first space, or a 1 in this first space. And then our other 2 digits for this first number is going to be the 2 and the 1. So we could put the 2 and the 1 here, and then here we're going to have the 2 and the 0 left over. Now, you could also have 2 minutes past 9, or you could have 12 minutes past 7 o'clock in the evening. That means there are a total of 4 possible arrangements where the 9 can be in the 2nd position. So there's 4 arrangements there. But of course, we said that the 9 can also be in the 4th position. Well, the 4th position is a bit more easier because there's no limitations on where the 2, the 0 and the 1 can be. The 2, the 0 and the 1 can be in either of these 3 spaces. So any 3 digits can be in the 1st position. The next 2 digits can be in the 2nd position, and then the last digit will go in the 3rd position. So that's a total number of arrangements of 3 times 2 times 1, which is 6. So there are 6 possible arrangements when the 9 is in the 4th position. So that means the total number of arrangements is going to be 4 plus 6, which is 10. So 10 possible arrangements. We've got an answer for 10, which is answer B. So therefore, final answer is B. Question 5. The answers to the 3 calculations below are written in descending order. We've got x is 0.6 times 0.5 plus 0.4. Y is 0.6 times 0.5 divided by 0.4. And then we've got z is 0.6 times 0.5 times 0.4. What is the correct order? Got answers for A is yzx, B is xyz, C is xzy, D is yxz, and E is zyx. Okay, so what we're going to do is we're going to evaluate x, y, and z, and then put them into descending order. X is 0.6 times 0.5 plus 0.4, so we're going to use BODMAS here. So the first thing is multiplication. So we're going to do the 0.6 times the 0.5, which is 0.3. Then add the 0.4. Well, that gives us 0.7. Y, well, we get 0.6 times 0.5 divided by 0.4. So division comes first. So what we'll actually be doing is 0.60 times 0.5 divided by 0.4, which is the same as 5 over 4. Now what I'm going to do is I'm going to change 0.60 into a fraction. So I'm going to say this is 6 over 10 times 5 over 4. And that simplifies to 30 over 40, which of course is 0.75, it's 3/4. And then we've got Z, we just multiply those three numbers together, the 0.6, the 0.5 and the 0.4. So we know that 0.6 times 0.5 is 0.30, times 0.40, which is 0.12. So in descending order, the highest value is Y, followed by X, followed by Z. And that is answer D. So therefore, the final answer is D. Question 6. The diagram shows part of a tessellation of the plane by a quadrilateral. Kellen wants to colour each quadrilateral in the pattern so that no two quadrilaterals that meet, even at a point, have the same colour. What is the smallest number of colours he needs? Got answers as A is 3, B is 4, C is 5, D is 6, or E is 7. Okay, so the key to this question is identifying a point where the quadrilaterals intersect. So in other words, where the quadrilaterals touch each other, and I'm drawing those points on the diagram here now, just so you can see. So they are all of our points, and what you'll be able to see is there's 4 quadrilaterals touching each point. So for example, if we look at this region here, got the first quadrilateral there, the second quadrilateral here, the third quadrilateral here, and the fourth quadrilateral here, and they're all touching this point here. So because there's 4 quadrilaterals that meet at one point, that means we need at least 4 colours for each quadrilateral. So if I rub this out, then let's say we shade this in blue, this quadrilateral's green, this one's red, and this one's yellow. Then we can have all 4 of these quadrilaterals as different colours, and then the pattern can keep on continuing. I don't know, this might be red, you might make this green, and then you can make this one down here blue. So the minimum number of colours that we need for this pattern must be 4. Got an answer for 4 is B, so therefore final answer is B. Question 7 says how many positive cubes less than 5,000 end in the digit 5? Okay, so if a cube number ends in a 5, we know that the number that we have to cube must also end in a 5. So for example, we know our first number is going to be 5 cubed, which we know is 125. Then our next number is going to be 15 cubed. Now we know that 15 squared is 225. Okay, so 15 cubed is going to be 225 times 15. So I'm going to work that out using a grid table. So that's going to be 200, it's going to be 20, it's going to be 5, and we can have 10 and 5 down here. We can have 200 times 10, which is 2,000. 20 times 10, which is 200, 10 times 5, which is 50, 200 times 5, which is 1,000, 20 times 5, which is 100, and 5 times 5, which is 25. If we add these together, gives us 5, 2 add the 5 is a 7, 2 plus the 1 is 3, and then 2 plus 1 is 3. So we get 3,375. Now the next number would be 25 cubed. Now I can tell you that 25 cubed is going to be bigger than 5,000. I don't need to work that out. It's quite obvious. If 5 cubed was 125 and 15 cubed was 3,375, I think it's pretty certain that we can say 25 cubed is going to be greater than 5,000. By all means, you can check. You can do the exact same check as what we did for 15 cubed. But based on this information, I can see that there are only 2 positive cubes that are less than 5,000. So that means our final answer is going to be answer B. So therefore, our final answer equals B. Question 8. 3 consecutive positive integers less than 20 are in ascending order, prime, even, and triangular. What is the product of these 3 integers? We got answers as A is 6, B is 60, C is 990, D is 1786, or E is 2730. Okay, so we got 3 consecutive positive integers which are less than 20. They're prime, they're even, and triangular. So let's think of all the prime numbers which are less than 20. Our prime numbers are 2, 3, 5, 7, 11, 13, 17, and 19. Our even numbers, which is pretty obvious, but I'll write them out. So 2, 4, 6, 8, 10, 12, 14, 16, 18. And then our triangular numbers. If you don't know what triangular numbers are, the way you can sort of represent this is with dots. So the first triangular number is 1. The second triangular number, we have 1 dot on the first row, followed by 2 dots on the second row. So that's a total of 3. Then the third term looks like this. So it's 1, 2, 3, 4, 5, 6. And then the fourth term is 6 add 4, which is 10. Then 10 add 5, which is 15. And then 15 add 6, which is 21, but that's greater than 20. So yeah, I'll just draw that below there. So we need to find 3 integers which are prime, even, and triangular, which are all consecutive, and then we basically need to multiply them together to get one of those answers. So you might pick out, say, 2, 3, and 4. But if you do 2 times 3 times 4, that's going to give you 24. That's not one of the answers. Could have 6, 7, 8. 6 times 7 is 42. 42 times 8. That's going to be 8 times 2 is 16. 8 times 40 is 320. So that's going to be 332. Don't have an answer for 332. So next we could do 10, 11, 12. So 10 times 11 times 12. Well, I know 12 times 11 is 132, and 132 times 10 is 1,320. I don't have an answer for 1,320 either. So what about 13, 14, and 15? Well, let's think about this. Well, I know 15 times 15 is 225. So 14 times 15 is going to be 210, and then 210 times 13. Now, that's going to be 13 times 200, which is 2,600, and 13 times 10, which is 130. So add those together, I get 2,730, which is one of my answers, which is answer E. So I think it's safe to say that my final answer is answer E. Question 9. What is the value of 7 minus 6 multiplied by minus 5 minus 4 multiplied by minus 3 divided by minus 2? Got answers as A is minus 17, B is minus 11, C is 31, D is 37, or E is 43. Okay, so again, we need to use BODMAS for this. So the first thing to think about is this bracket here. So 7 minus 6 multiplied by minus 5. Because we're dealing with this first bracket, we need to think what's the first operation within this bracket? Well, it's multiplication. So we're going to do the minus 6 times the minus 5 first, which is 30. So then we're going to be left with 7 plus 30, which is 37. Okay, now let's look what's left over. So we're going to have 37 minus 4 times minus 3 divided by minus 2. or using BODMAS, the next operation is division. So we're going to have minus 3 divided by minus 2, which is the same as 3 over 2. And then multiplication is going to come before subtraction. So we're going to have minus 4 multiplied by 3 over 2, which is minus 6. And then we're just left with 37 minus 6, which is 31. Got an answer for 31, which is answer C. So therefore, final answer equals C. Okay, question 10 says a recent report about the amount of plastic created in the last 65 years stated that the 8.3 billion tonnes produced is as heavy as 25,000 Empire State Buildings in New York, or a billion elephants. On that basis, how many elephants have the same total weight as the Empire State Building? We've got answers as A is 4,000, B is 40,000, C is 400,000, D is 4 million, or E is 40 million. Okay, so to work out how many elephants have the total weight as the Empire State Building, we need to do 1 billion, which is basically a 1 followed by 9 zeros. And then we need to divide this by 25,000. Now, you should know that 1,000 divided by 25 is 40. So what's going to happen is these zeros here are going to cancel out. You're basically doing 1,000 divided by 1,000, which is 1. And then we've got another 1,000 here left over. So we're therefore going to have 40 followed by 3 noughts, which is 40,000. And we've got an answer for 40,000, which is answer B. So therefore, final answer is answer B. Thanks for watching the video, guys. Don't forget to subscribe to my channel. I've also left a link in the description to my website, and you can also check out any other videos from my YouTube channel on this page.